Chapter 12, Area and Volume of Solids. The first section is concerning prisms. Prisms are three-dimensional figures that start with a pair of congruent parallel polygons called bases. When you connect corresponding corners, you get prisms. You get a prism. So here are two congruent parallel polygons, and they look to be square. So if I connect corresponding corners, you can see the shape that evolves. And I'm just going to make a dotted line in the back. Because you would not be able to see this if you were, okay, not very straight, but you get the idea. So let's go ahead and do the other ones. We're going to connect the corresponding corners, and now there would be two in the back, and I will put them in, but they would be more like dotted lines if we were doing perspective drawing. And this last one would look like this. So these are all examples of prisms. I'll see if I can do this. This should be a straight dotted line. Okay. So some definitions that go along are that the two parallel polygons are the top, often they're top and bottom, but they may not be. For in this example over here, the bases are not top and bottom, but they're on the sides of the drawing. Those are the bases. Lateral faces are the other sides, not the top and bottom or the bases, but the other side. So for this third example, there are three lateral faces. There's the bottom one, the one on the right side here, and the one on the left side, which would be in the back of the drawing. Lateral faces. Lateral means sides. Lateral edges are the edges of the lateral faces. So here's an example of a lateral edge. An edge would be here, there would be one up here, and one over here. An altitude is a segment between the two bases of the prism parallel to, an altitude is a segment between the two bases perpendicular to each other. So in this drawing right here, the altitude would be, maybe any of these lateral edges would be an altitude. Usually we call it the height, h. It would be the distance from the base to the base. Now in this drawing, the base is up here and there's a base down here. So the altitude would be the perpendicular distance between the two bases, the height. Notice that the altitude lives outside the prism in this drawing. A right prism, in a right prism, the bases are directly above or across from each other. The lateral faces of a prism are blank. So which one of these drawings are a right prism? They have to be directly above each other. So this first one is a right prism. This one is not, because the bases are not above each other. These are directly across from each other. So this is a right prism. And in a right prism, the question becomes, what about the lateral faces? So if I look at this face here, there are four faces in this right prism, and they look to have the shape of the same shape of these three faces in this right prism, and those shapes are actually rectangles. They are rectangles. In a right prism, the lateral faces are rectangles. In an oblique, a prism that's not right, just not right. So the middle prism is called an oblique. We don't do a lot of work with obliques, but I like for us to look at them. And if you look at an oblique prism, what about the lateral faces in an oblique prism? They are parallelograms. Parallelograms. Prisms are named by the shape of their bases. Some examples are triangular, right regular hexagonal prism, isosceles triangular prism, or oblique pentagonal prism. So those are some ideas of names. So triangular prism would be like the one on the right up top of the page. A right regular hexagonal prism would have a hexagon on top, which are 6 sides, and directly below it would be another hexagonal base, and that would be a hexagonal right regular prism. Isosceles triangular would have an isosceles base of a triangle, and then it would have the rest of it. I don't think the top one is an example of an isosceles. Oh, I'm sorry, isosceles. That would mean, not thinking of obtuse. Isosceles would mean 2 of the sides were congruent, and actually the top prism is an isosceles triangular prism. An oblique pentagonal would have 5 sides of the base, 2, 3, 4, 5, and the bottom would not be directly underneath, so it might look somewhat like this. I can't get that to work, and now all kinds of things are happening. So let me get out of this. So let's turn to the next page. This surface area, or the total area, is the combined area of all the bases and faces, and the lateral area is just the side. Lateral again means sides. So considering the right equilateral triangular prism shown, we need to find the area of the 2 bases. Again, right refers to the prism, not the triangle. So this is an equilateral triangular prism, and it's a right prism because the bases are on top of each other. To find the area of the 2 bases, we would do what we did in the last unit, and we would know that these are a 60, 30, 90 triangle. The hypotenuse is 6, which is 2 times the area, the length of the shortest side. And of course this is 3 because this is 6, and you don't even have to do that. And this is 3 root 3. So the area of the 2 bases is 2 times 1/2 base times height because of the 2 triangles, the 2 bases. And the base is 6 and the height is 3 root 3. So combining through 2 times 1/2 is 1. 6 times 3 is 18, so the answer is 18 root 3. The lateral area is just the area of the 3 rectangles, and each of the rectangles has an area of 48, 8 times 6, so we would do 48 times 3, which is 96. I'm sorry, 144. 144. And the total surface area, you would add them. 144 plus 18 root 3. Okay, so I want you to find the lateral area, which means the side area of this octagonal prism without using a calculator. So I want you to find the side area. So it gives you information about the side, and it gives you information about the height. Basically, we want to find the area of all the lateral faces added. So I want to see if you can do that. And we'll check this answer tomorrow in class. And go to the next page, and we'll fill in some of these facts. The first fact is that the lateral area of a right prism is defined as, actually, we'll do this in class tomorrow because this comes directly from the activity before. Let's go to the volume, and the volume of a right prism is the area of the base times the height. So you imagine in the page before filling that swimming pool with water. You start with filling the area of the base, and then you keep filling up as high as your structure is. So volume is the area of the base times the height of the prism. In a right rectangular prism, by the way, this only works for a right rectangular prism. What would happen here? Well, if I wanted to get the area, the base area is 12, which is 6 times 2. And the volume, I would take 2 times 6, which is 12, and I would multiply that times 5 to get the volume filled in. And so that would be 12 times 5, which is 60 cubic units. So the volume only of this structure is length times width times height, only of a right rectangular prism. In general, which is really what we want, in general, for any prism, the volume is defined as the area of the base times the height. The area of the base times the height. So here, the area of the base would be this down here. And to get the volume, we'd multiply that by the height, which would be from the top perpendicular to the bottom. That would be the height. If you wanted to find the area, the volume of this oblique prism, you'd find the area of the base and multiply that times the height, which would be the perpendicular distance from the two bases. And we're done for today.